Welcome to the first day of the rest of your life, the day you decide to live your best life sooner.
Good things come to those who don't wait to invest. Coronation. Trust is earned. Coronation is a registered FSP.
Good day, good day, good day, good day, good day. How are you doing on this beautiful Monday? Um, Good day. Come on in, come on in, come on in, come on in. It's that time of the day that we assist each other and interact together and have nice time with some mates. Come on in, come on in. Share the link, share to the friends, and say that we are live. We are live now. So today we'll be doing mathematics paper 1 revision. The past 2 weeks we were practicing analytical geometry, trigonometry, as well as Euclidean geometry, which is paper 2. So today I'll be doing functions and calculus, the core of paper 1 after algebra, which is all for x. Can someone just say something in the comment section so that we see that we are together? If it's your first time to tune in, don't forget to subscribe. Don't forget to like. Don't forget to share with friends. Also, in the description of the video, there is the link for the WhatsApp channel or the WhatsApp group where we assist each other each and every week. We provide you with papers, combined papers that you practice. If you have any question, you can ask us anytime so that we can assist each other. The goal is for you to pass, for you to get higher marks and be able to apply for university. Great, great, great. So today we'll be doing calculus as well as functions. So there are 2 videos or 4 videos actually, which are on the Yebo Tutor channel, which we explain deep about functions. We go deep into functions. We give you an overview that when we're talking of functions, we have 4 or 5 different functions which we will look at. So we have like the straight line, we have the parabola, we have the hyperbola, the exponential function, and the inverse function or the log function, which is introduced in grade 12. And we must be able to understand the range and the domain of all those functions, and we must also be able to plot those functions, and must also be able to determine the shifting of the function. So for instance, if they say that the graph has been shifted 2 units upwards, you must be able to know where are you supposed to shift your function. Then we have calculus. Then on calculus, we also explained on those videos that we have what we call the differential calculus, and we differentiate according to the first principles. Then that's when you must explain and must do the whole question, and you must be able to solve it from the first step. F prime of x is equal to the limit of h as h approaches to 0 of f of x plus h minus f of x divided by f of x. Then after that, you solve pertaining what you already been given, or on that specific function which you have been given. Then now we also say that on calculus we can be able to use the power rule, whereby now we no longer have to differentiate according to first principles, but we just apply dy dx, or maybe we can apply f prime of x, g prime of x. It depends with which variable or which function which you are given, then you can be able to solve. Then after that, we also have optimization in calculus, which means now you must be able to understand what you are given. For instance, that sometimes you are told about a rate of change, I must told by like it has reached the maximum, those kind of things. You must be able to apply them and be able to use them properly. So now let's get to the business of the day. So now we know that concept. Now we have the basics. Now we have the foundation of functions as well as calculus. So please, if your foundation is not strong, I urge you to watch the video of calculus, which is separate, and also the video of functions, which is also on the Yebo Tutor channel, so that you can get to know the concept in a deeper way. Okay, before you attempt questions, Bear in mind that we are preparing you for your June exams. So actually it's hashtag June exams preparation. So now let's get down to the business of the day. If you have any question, please don't forget to type on the comment section. I'm here to assist you. Together we go further. Right. Great. Now, as you can see on the screen, we are having the question paper for June 2015, paper 1. It's interesting. June paper 1, 2015. The setting of the questions, they're always the same, always. They don't change how they set questions. For instance, we know that on paper 1, we have calculus, we have algebra, 25 marks. We have number patterns, plus or minus 25 marks. We have functions, which are the core, which is 35 plus or minus 35. We also have calculus, which is plus or minus 35. Then we have financial maths, which is 15 marks, as well as probability, which is 15 marks. So the way they set questions, they don't change. It's still the same thing. So today we'll be doing June exam, June question paper for 2015, which comprises of everything. We'll do next week, we'll do solving for X. Solving for X is quite easy. Please do check the video. It's available as well of solving for X, where we call and talking where do we find X. All right. So now let's get down to the business of the day, which is functions. So we're gonna do all the questions for functions, and we're gonna look at calculus. Okay. All right. Now let's get down. So the diagram, question 4. Now on the diagram which we are given, the diagram below shows the graph of g of x equal to a over x minus 1 minus 2. The point 0 is to negative 5 is situated on the graph. It's located on graph of g. Now, what do we know and what do we understand by the equation which we are given? The moment we see that equation, our mind must run that this is a hyperbola. So since this is a hyperbola, we must know that we have the horizontal and the vertical asymptote, which we must be able to determine. Or for instance, we must be able to know from the get-go. So the core, or the how you attempt questions, is by you read the statement and understand, and you analyze before you try to answer the question, so that you can actually have the big overview of what's really going on. So for instance, now we know that this is a hyperbola. What do we know about a hyperbola? We know that it has a horizontal and a vertical asymptote. We also know that the range of the function, we look at the value or the horizontal asymptote. So those things are the key for you to be able to analyze everything. So now let's get down. Question 4. Question 4. Great. On question 4 now, what is important is to be able to understand the key that now this is our function which you are given, and we can see that that is a point 0 to negative 5, and you can see that that point say y intercept, because we say that when we are calculating for y intercept, we always say that let x be equal to 0. So for the fact that you're already given a coordinate is 0 is to 5, that specifically tells us that that point of which is given on the graph, it's a y-intercept of the function. So when we want to calculate the value of a, we know that we can actually use that point which already been given on the function, and you substitute on that equation, then we can actually get the value of a. But we have not yet attempted the questions which we're asked to attempt. So the key in answering the questions in maths is that you must be able to get the concept and analyze the statement and the diagram which you are given before you attempt question, so that you must ask yourself, which kind of graph am I dealing with, and what do I know? We must know that we have the axis of symmetry, we have the positive and the negative axis of symmetry, since it's a hyperbola. So those key concepts must be able to assist you to have the basic, or to be able to attempt the questions. So now let's get down to 4.1. Now they say write down the range of G. You see, now we already analyzed, we already know that, okay, in order for us to know the range of G is the same as, we just look at the horizontal asymptote. What is our horizontal asymptote? Okay, let's write down. Okay, great. Now, question 4. Now, 4.1, they asked us one question. They asked us the first question, determine the range of the function. How can we determine the range of the function? So analyzing the question before we write 4.1, let's analyze it. So we are given g of x, which is equal to a over x minus 1 minus 2. Then we are also given the y-intercept. Why are we saying it's a y-intercept? Because we are saying that x is already related to 0. So that's definitely telling us that that is a y-intercept. So now we must also know that now analyzing the equation which they give us, this is a hyperbola. So since it's a hyperbola, what is our x? The vertical asymptote, we know the vertical asymptote will be x is equal to 1. Then we know also that the horizontal asymptote y is equal to negative 2. And you can actually see that as well on our graph. So what is important is to be able to see those few things before you attempt to write your questions. Okay, so now let's go to 4.1. Let's go to 4.1. Let's go to 4.1. Okay, 4.1. What is the range of the function? So what did I say when we're determining the range of the function? What do? We said that we look at the horizontal asymptote. So 4.1, what is our horizontal asymptote? Y is equal to -2. So what are you going to do? Y is an element of real numbers where y is not equivalent to -2. As you can see, the graph is increasing from negative infinity to positive infinity, but at y equal to -2, that's the asymptote. The graph doesn't touch the asymptote. So the moment your graph doesn't touch the asymptote, which means that specific value is excluded. And now what do we know? We know that real numbers are numbers which start from negative infinity to positive infinity. So that will be the range of the function. So 4.1, the range of g will be y element of real numbers where y is not equal to -2. 4.2, determine the value of a. How can we determine the value of a? We are already given a coordinate on the graph, so that's easy. So we can just say substitute 0 is to -5 in y is equal to a over x minus 1 minus 2. So what do we know? We know that this is y, x, and y. So now we can just substitute in the original equation which we were given initially. -2, great. So it's gonna be, where is y? Or y is -5. -5 is equal to a over, what is our x? Our x is 0. So it's 0 minus 1 minus 2. Then that will be -5 is equal to -a, because 0 minus 1 is -1. Then 1 divided by -1 is -1. Minus 2. Then we transpose, so it's gonna be -3, -5 plus 2 is equal to -a. Then -5 plus 2 is -3. -a, we divide by -1. Then now we know that our value of a is +3. Just as simple as that. So what did we do? We substituted the value or the point or the coordinate which we were given in the function. Then we're able to determine our function of the graph. Okay, great. Now let's move on to 4.3. So on 4.3, what did they say on 4.3? What do they want from us? 4.3, what do they want? They say that if another function h is defined as h of x is equal to g x minus 3 plus 7, determine the coordinates of the point of intersection of the asymptotes of h. So in other words, you must be able to reflect the original function which you are given so that you can be able to have the new coordinates of the point of intersection. So the point of intersection now, which already tells us that is going to be a coordinate x and y. So initially we were given g of x, which is equal to 3 over x minus 1 minus 2. So what do we have here? So now the graph now of g of x, you can see that h of x, it's a graph which is equal to g of x minus 3 plus 7. So on the x, we can see that it has been shifted 3 units to the right. It has been shifted 3 units to the right. Since it's -3, then plus 7, which means it has been shifted 7 units upwards. So it's going to change on it's going to affect the value of q and the value of p. So how do we do that? Now we can substitute so that we can get h of x. H of x will be equal to 3 over x minus 1. It has been shifted to the right. So how do we write it down when it has been shifted to the right? We must understand that it has now been shifted to the right. So since it has been shifted to the right, now we must just be able to substitute there and say x minus 1 minus 3. Then we have -2 plus 7 because the graph has been shifted. So that is what is important. That is what is the key in the process. Okay, so it's -1 minus 3 minus 2 plus 7. Then now we have 3 over x minus 4. Then 7 minus 2 is +5. Okay, that's +5. So we need the intersection of the coordinate or the coordinate intersection, or where the point, the horizontal and the vertical asymptote intersect. So we know that the vertical asymptote will be x is equal to 4 and the horizontal will be y is equal to 5. So the intersection will be 4,5. Then we are done with that question. So how did we solve this one? We were told that h of x is a function which comes or is derived after g of x has been reflected 3 units to the left. So when it's negative 3, we must know that it's 3 units to the right, 3 units to the right. The fact that it's a minus sign is 3 units to the right. So how does it affect? It only affect the value of p. So initially, maybe for instance, we are given our original function y is equal to a over x minus p plus q. So we are saying that it will affect the value of p horizontally. Horizontal only affect the value of p. Then q is representing on the y. So it will affect the y value. So since we are given initially negative 2 and now we are given positive 7, which means the graph has been shifted 7 units upwards and it been shifted 3 units to the right. Then after that, the point of intersection. So we started by finding the function of h of x. So our h of x was equal to 3 over x minus 4 plus 5. So what do we know? We know that in order for us to have our horizontal and vertical asymptote, we take from the function. So the horizontal asymptote, the new horizontal asymptote will be y is equal to 5 and x is equal to 4 will be the vertical asymptote. Then we intersect them. We know that a point of intersection, that's where they meet. So this point now is 4, 5. That was our question 4. Is there anyone with any question? That was our question 4. Okay, great. Seems like we are all on the same boat. Now, let's move on to the next question. Question number 5. It's quite long, but interesting at the same time. Okay. So initially we're given f of x is equal to 1 over 4 to the power of x. All right, that's great. So what are we given? We're given an exponential function. What do you know about an exponential function? Exponential function only have a horizontal asymptote. So now we're given f of x, question 5. So we're given f of x to be equal to 1 over 4 to the power of x. So we are given that function now. Now let's look at what we are given. Let's solve what we are given, guys. Okay. 5.1, they say that determine the value of f of negative 2. Determine f of negative 2. F of negative 2. So now we are determining the f of negative 2. So how do we determine f of negative 2? So what are we given? Initially we are given f of x is got 1 over 4 to the power of x. Now we must determine f of 2, which means the place of x now we're going to substitute with 2. It's going to be 1 over 4 all squared. So we use our calculator. Oh, sorry, it's negative 2. It's going to be negative 2 as well here. So when we use our calculator, what is our solution? Use your calculator. We know that it's going to be 4 squared, and 4 squared is equal to 16. So f of negative 2 is 16. Then our next question, that was easy and straightforward. Write down the equation of f prime of x, which is the inverse of the original function. So 5.2. So we say that when we're doing inverse functions, we say that in order for us to determine the inverse of a function, so we start by writing the equation, the original one, in the terms of y. Then after that, we swap x and y. So where there is y now, there will be x. Where there was x, there will be y. Then now we solve for y. How do we solve for y? We apply the log. Then now it's going to be log of 1 over 4 of x equal to y. So therefore, y will be equal to log of 1 over 4 x. Okay, that will be our inverse function. Okay, now 5.3. Andrew has no idea how to draw the graph of the the inverse function of the original function. Okay. Explain to Andrew how he may use the graph of f to draw the graph of f prime. How will he be able to do that? How can you use so that's easy. What do we know? What is important is to understand that when we are drawing those functions, they sort of like it's a mirror, so it's like a reflection on one another. So this one is initially like this, so when it's reflected now, it's now looking in the other direction. For instance, if we're given a point which is 2:5, now this point now will be 5:2 because it has been reflected along the line y is equal to x. So what is important is to understand that the inverse function is basically telling us about the inverse function and the inverse function now is just taking us sort of like it's a mirror of the original function. So if the original function has the coordinates of 2:5, now it has been reflected along the line y is equal to x. So now the mirror of the original function will be the inverse. So now you just swap the coordinates. So if it was 10 is to negative 5, so now the inverse function will have -5 is to 10. So it's just like that. So how can you explain to Andrew in English now? Now you can say to Andrew now, when you're answering your paper, you can say to Andrew that she must understand that Andrew that f and f inverse are symmetrical. They are symmetrical about the line y is equal to x. So to obtain the inverse function, which is f negative to the power -1, you must reflect f in the line y equal to x. So the same way I explained there, but now you're now writing in sweet English so that Mr. Andrew can understand that, oh, okay, this is how you can do it, and write it in a better English, and so that you can understand, okay? Because you're not supposed to like show that 10 -5, you're supposed to write in English. So this is the English which you can actually write, okay? Or you can actually say that the x and the y coordinates of the original function of f may be swapped around to obtain the coordinates of the point. So what I was saying here, it's -5 and 10. Now you can write now in English. Now you cannot just say e.g. and say that -5 and 10. So write it in English that these are the original coordinates of the original function, which is 2:5. So I say the original coordinates, which is the original x and the y coordinates of the original function will be swapped. Then you can actually put an example, e.g. 0.2.5 can be swapped to be 5,2 on the other on the inverse function. So that's how you must be able to explain your function. Now the next question now on 5.4, hence or otherwise. When they say hence, that English means that use what you have already solved, use what you have above. So hence or otherwise, sketch the inverse function of f on your answer book. Clearly indicate all the intercepts with the x's. Okay, let me just draw both of them, the original one and the inverse one. So now let's draw the first one. So we are given that f of x is equal to 1/4 to the power of x. This tells us the horizontal asymptote of this function is equal to y equal to 0. Why? Because the original formula, when we are writing the exponential function, you know that abx plus q, where q is now representing the horizontal asymptote. So in this instance, we are not given the value of q, which means the horizontal asymptote is already y is equal to 0. So you must understand it's y is equal to 0. So now plotting our function now won't be difficult, because now y is equal to 0. So this is the x and y. Great. So now we know that y is equal to 0 is the asymptote. So your graph must not touch y is equal to 0. And when we determine the y-intercept of the function, how can we do that? Y-intercept, we say that we let y-intercept, let me just use a different pen so that you can see that as well. Great. So y-intercept, we let x to be 0. Y-intercept, we let x to be 0. So y will be equal to 1/4 to the power of 0. Then our y value will be equal to 1. Anything to the power of 0 is equal to 1. Trillion to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So 1/4 to the power of 0 is equal to 1. So therefore, we now already have a coordinate 0 is to 1. So now the original function now, it cannot touch y is equal to 0. Let's say this is our 1. It cannot touch 1 is y is equal to 0, because y is equal to 0 is our asymptote. So we have a point here. So it's going to be an increasing function. Here we go. Okay, this is our function of f of x. So that's how you plot your function of x. Now this is a point 0 is to 1. Okay, now we say that when we're explaining to Andrew that Andrew, in order for you to be able to plot the inverse function, what are you supposed to do, Andrew? You must be able to understand that f and the inverse function, they are symmetrical about the line y equal to x. So now what you explained to Andrew is now what you're supposed to use here. So we say that it has been reflected now along the line y equal to x. So in other words, we want the mirror of the function which we had initially. So this is now the mirror which is reflected upon the line y is equal to x. So since we had the point 0:1, now the point now will be swapped to be now 1:0, because the original function has been reflected, has been mirrored on the line y equal to x. So now our new point will be equal to 1:0. So on our function now it's gonna be 1:0. Then after that we can actually plot our function just like that, because it's a mirror. Because it's a mirror. Okay, so that will be our function. This is the f inverse, and this is our original function. So I drew both of them, but in the question they say draw only f inverse. So I did that so that you can actually see the beauty of what's happening here. Okay, cool. 5.6. They are saying that for which values of x will f inverse of x be greater or equal to -2? For which values of x will be the inverse function be greater or equal to -2? So we can see, where is this function greater or equal to -2? Greater or equal to -2. We can see that it is the inverse is greater or equal to 2 when x is greater than 0, because you can see that it cannot touch this function, but at this point it will be greater or equal to -2. So the answer will be just as simple as that. Oh, sorry, I skipped 5.5. I didn't see that one. I just able to see it. 5.5. Write down the domain of f inverse. What do we know? We know that the domain of an inverse function is the range of the original function. So that won't take us time, because we must understand that if that's the truth, so then our range, our domain in this case, domain of f inverse of x now will be equal to, x greater than 0. Why is x greater than 0? Because we see that initially the range was y greater than 0, because you can see the original function here, it cannot touch the horizontal asymptote, which is y is greater than 0. So the range of the original function now will be the domain of the inverse function. So you just swap. So everything is being swapped. If it was the domain of the original function, it will be now the range of the other function. Just like that, that's how you solve it. Now I just did a mistake here. 5.6. That's why I came back again. So on 5.6 they're saying that where is the function the inverse function greater or equal to -2? So you can solve this in two ways. Okay, you can actually determine f prime and solve the inequality. Okay, where's the inequality? So f inverse is log 1/4 of x. So you can actually write here log 1/4 of x greater or equal to -2. And after that you can just say critical value so that you can equate it to the equation. So log 1/4 of x will be equal to -2. Then x will be equal to 1/4 of -2. You see, that's why I say that when they say hence, use what you have initially, because initially on the first question they told us that determine the value of f to the f of -2. So now we can also say f of -2 is the same as what we have already calculated initially, that f of -2 is 16. So that's the same thing which you must also have. So when they say hence, don't worry yourself. Use what you have above. Use what you already have solved and use it so that you can actually not waste time. So now in this instant our x will be equal to 16. Or x will be equal to 16. So now let's come to our graph so that we can analyze it. So in order for us to determine the values of x for which this graph is greater or equal to -2, now let's look. We can see that the inverse function is not touching 0. Why? Because now the horizontal asymptote is now y is equal to 0. So it's not touching the asymptote, which means now between 0 and 16, we can actually get the values which are greater or equal to -2. So since this, we now know the x value, so now we can actually conclude that it must be between this interval from 0 to 16. So other one can say x must be the element from 0 to 16 with using included brackets so that you don't do mistakes on that part. Then we are done on that 5.6. Now let's do 5.7. Let's do 5.7. Let's do 5.7. 5.7. Okay. So on 5.7, what do we have here? They're saying that given Q is equal to log 4 of 1 over 2. Determine the value of Q. Wow. So you must just use your calculator just like that. They were just playing with our minds. It's already something given. You just have to use your calculator and solve it. So you just write and solve for Q. So 5.7.1, we already know that if that's what we must be able to do, that won't give us problems because the function is already given. So you just use your calculator and get the correct answer. Okay. So when you're writing your questions, please be articulate and be able to realize what you are given and analyze it first before you write anything else. Okay. Now on 5.7.1. Okay. So on 5.7.1, we are given that Q is equal to log of 1 over 4, 1 over 2. Then you can just solve it, or you can use your calculator. You just use your calculator so that you can get one value. So you're going to get that Q is equal to 1 over 2 when you use your calculator. Okay. Then the next one is 5.7.2. 5.7.2, they say that now. Hence, so you see the hence is telling us that use what you have already determined on 5.7.1. Hence or otherwise, determine the coordinates of the point of intersection of F and the F inverse. Determine the coordinates of point of intersection of the both graph. Okay, so how do we do that? In order for us to determine the point of intersection, how can we do that? So this actually means that on this function we're given log of 4 1 over 2 is equal to 1 over 2. 1 over 2 is representing y and 1 over 2 is representing x. So what is the point of intersection? So you can just write x is equal to 1 over 2, y is equal to 1 over 2. Then therefore the point of intersection will be 1 over 2 is to 1 over 2, just like that. So you didn't have to calculate many things. It's something which you already have in your equation. So what is important is to be able to know the notations as well. Okay, cool. So now we knew, so we were given this, so they told us log of 4 of 1 over 2 is equal to 1 over 2. So what do we know? We know that the original form of a function, it's log a, which is represented, let me just use b so that you don't say, confuse you, b, x is equal to y, where b is the base, x is the x, and y is the y value. So now they have given us in this form, in other words, b is 4, x is 1 over 2, y is also 1 over 2. Then now we can actually definitely have our point of intersection, because point of intersection must have x and y coordinate. So those are my functions, especially the grade 12 functions. They're a bit tricky. So there were 14 marks, 14 plus 7, that's 21 marks. So those 21 marks, you already have them, you put them in your bag. Okay. Now we have those marks, we no longer worry. No longer worry since we have those marks in the bag. Okay. Is there anyone who has a question, guys? I was checking on my comment sections. No one said something, which means we are cruising together. We are enjoying. Which means we are enjoying together. Cool. Those are my functions which I wanted to do today with you guys. Oh, this one seems to be interesting. So let's just do all functions as well. Let's just do question 6 first. Let's do question 6 first. So the sketch below shows the graphs of g of x equal to negative 12x plus 12 and f of x is equal to negative 3x squared minus 9x plus 30. A and B are the x-intercepts of f, and C is a point on f. D is a point on G such that CD is parallel to the y-axis. H and K are the points of intersection of both function of f and g. Oh, this is great. Let's analyze. G of x is a straight line. We already see that. It's in the form of y is equal to mx plus c. then f of x, we can actually see that since it's an x squared, which means that is a parabola. So what do we know about a straight line? We know that the domain of a straight line, x is element of real numbers. What's the range? Y is the element of real numbers. Done, dusted. If you want to know it, you must be able to understand only the y-intercept and the x-intercept in order for you to be able to plot it. Done with the straight line. Great. Now, on the parabola now, which you are given f of x, definitely you must know the x and the y-intercept, the x and the y-intercept. How do you determine the x-intercept? You let your y be equal to 0. How do you determine your y-intercept? You let your x to be equal to 0. And also on a parabola, we have what we call the axis of symmetry. And how do you determine the axis of symmetry? We say that on one of our videos that x must be equal to negative b over 2a. Then we can actually get our axis of symmetry. Then also a parabola, it's a graph which has a turning point. Turning point, 10. So that turning point is calculated. So you must also be able to see that, oh, okay, this is the function which you are given. So where is the turning point? So in this instance, they just gave us the alphabets A, B, C, H, D. So now let's look at the alphabets they give us. A and B, we can see that those are x-intercept because the y value on A is 0 and also on B is 0. Then now we already know that you must be able to determine those coordinates of A and B. Okay, we also have C. Oh, all right. We also have D. D is a point on G of x. But G, D, and C, they have the same x-intercept because they are just reflected or have been shifted. That point D has been shifted on the y-axis. Oh, all right. Just like that, now we already also see that H and K, they are the point of intersection. What does the point of intersection mean? It means that both graphs or two graphs, they intersect, they meet. They meet. So at that point in which they are meeting, that's what's important. So what is important is to be able to analyze the question. Now let's go to the question. Let's see. Determine the length of A and B. Where is A? A is here, B is here. What do we know about A and B? We know that A is an x-intercept of the function. B is also the x-intercept of the function. So you just determine the x-intercept of the function of f of x. Then after that, you use the distance formula DAB is equal to x2 minus x1 all squared plus y2 minus y1 all squared. Then after that, you put it under the square root. Then after that, you get your final answer as the distance of AB. Okay, so what we analyze is what we are actually being questioned. Now they say determine the coordinates of K. What do we know about K? We were told that K and H are the point of intersection of the function. So in other words, you must equate G of x and f of x to be equal to each other. Then you solve for the x and the y value. Then after that, you can actually have the coordinates of K. So that's how you must be able to analyze your question. What is important is to be able to analyze your question according to what you were given in your statement. So if you get your statement incorrect and understand it, so if you get your statement which you are given and understand the statement which you are given, everything will be perfect for you. Okay, let's solve the question. Let's solve the question. Question 6. Question 6. Question 6. Great. Question 6 now. Let's determine first. 6.1. 6.1. They say that determine the length of AB. Let's start by calculating the coordinates of A. What do we know about the function of f of x? We are given that f of x is equal to y, of course, is equal to negative 3x squared minus 9x plus 30. So now A and B are the x-intercept. A is 0 is to is x is to 0, and also B is x is to 0. Now these are the y-intercept. So you can these are the x-intercept. So you can just say x-intercept. Write this English. You see, so that the marker will see that no, you know your stuff, you know your work, so that he or she can be impressed and find your work neat. Write this more English, that x-intercept, so that we know how did you determine the x-intercept. After that, you let your y be equal to 0. Now let's go and attack. Now 0 will be equal to negative 3x squared minus 9x plus 30. Now that we can use our quadratic formula. Don't worry about finding factors now. If you can't find factors now, don't worry about it. Use your quadratic formula. It's always there to save your day. Don't even stress about it. Use your quadratic formula and get your x values. So let's go now. If you're going to use factor form, we know that negative 3, you divide all through by negative 3 is going to be x squared plus 3x plus 10. If you're going to use the factor form, we start by equating it. Then after that, how can we move forward from that? We know that the factors here will be x, it must be plus 5, x plus 2. Is that correct? Other must be positive, other must be negative. Sorry, here to be negative because plus and negative would divide each other, so it will be negative 2. Great. Then after that, therefore, we have our x to be equal to negative 5, or our b will be, our x will be equal to positive 2. So looking at the function which we're given, we can actually see that which coordinates will have the positive and the negative. A is on the far left, which means a now will be negative 5 is to 0. And what is our y? Our b now is on the positive, so it's going to be 2 is to 0. Then after that, we are told to calculate or determine the distance of AB. So how do we determine the distance of AB? You say distance of AB. Now, what you were taught in analytical geometry is what now you apply. It is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so now let's go AB. So our B will be everything squared. So it's going to be 2 minus 5 squared plus 0 minus 0 all squared. Then we know that 2 minus 5, that will be 7 squared. 7 squared is 49. Square root of 49 is 7. Don't worry. Use your calculator. Use your calculator. Don't try to use your mind. Use your calculator to be able to determine those values. All right. So we actually see that AB is 7 units. So the moment you are here, use your calculator. Use your comparator and get the values. So distance of AB is 7 units. Right. So let me just do this one last one, which is 6.2, so that we can actually go and do calculus as well. 6.2 now. 6.2, they say that to determine the coordinates of K. So when we were reading the statement, we were told that H and K, they are the points of intersection. So if they are the point of intersection, what does that mean? It means that these two graphs, they are equal to each other, that specific point. So now the first thing which you must understand is to write that f of x will be equal to g of x, because that's a point of intersection, which means those two graphs, they are equal in coordinate form. So great. What is our f of x? It's negative 3x squared minus 9x plus 30 is equal to g of x is negative 12x plus 20. Let me just double check that as well. Great. Plus 12, sorry. Then after that, now we mix the like terms. So we can see that it's going to be negative 3x squared minus 9x minus 12 plus 30 minus 12. Okay, is this correct? Oh, it's plus 12, sorry. Then negative 30 minus 12 is equal to 0. Negative 3x squared, negative 9 plus 12, 12 minus 9, that will be 12 minus 9, that will be positive 3x. 30 minus 12, that will be negative positive 18. Then after that, the same thing, we divide through by 3, then it will be x squared minus x minus 6 is equal to 0. So you can use your calculator as well. Okay, then when you are here, or when you are actually here, use your quadratic formula. If you don't know how to find factors, don't stress yourself. Quadratic formula is there for you. Okay, then if you are looking for factors, you know that will be x minus minus 3, then x plus 2 equal to 0. Then therefore our x will be equal to 3, or our x will be equal to negative 2. But looking at where k is, we can see that k is on the a positive x-axis. Do you see that k is located on the positive x-axis? So now, in order for us to get, we already know that now k now, therefore k now is now 3 is to y. So now let's calculate for y. So you can substitute k 3 comma y in g of x. You can substitute in one of the function. You can substitute in g of x or in f of x. But I love g of x because g of x is negative 12x plus 12. It's quite straightforward. So it's going to be y is equal to negative 12 times 3 plus 12. Then our y will be equal to negative 12 times 3. That's negative 36. Negative 36 plus 12. That's 12 minus 36 That would be negative 24. Negative 24. Negative 24. So you guys, you use your calculator. The moment you do, what is important, just do your substitution in the correct formula, then use your calculator. Don't think about many things. Don't find factors. Use your quadratic equation so that you prevent wasting time and dwelling on one thing. Okay. Then after that, you can actually see that as your answer. Right. Now, the next question, they say that determine the values of x for which f of x minus g of x is less or equal to 0. That's also easy because 6.3, this is my last question on functions. So f of x minus g of x must be less or equal to 0. Of course, it's going to be f of x is less or equal to g of x. When we transpose g of x to that other side, then after that, you can actually see that when you look for the critical values, let me just show you that. If we want to look for the critical values, because this is now an inequality, when we say critical values, we can actually see that f of x is equal to g of x. So this is going to give us back to these two values which we have already calculated. So now we must actually determine and use those two functions. So we can actually see that now we draw our. So initially we say that when we have these two equal to each other, that's what is our answer. Then after that, you can actually use those values, which is x is equal to 3 or x is equal to negative 2. So negative 2 here and 3. And we know that when it's less than, now our function won't be found inside. It must be outside. So therefore, you can write that x is an element from negative infinity to negative 2 included, or union from 3 to positive infinity. Then we can actually say that that will be our answer. That will be our answer where those functions are less than equal. So solve them, then you get the correct values. All right. Now let's do calculus, guys, because of time. Let's do calculus. Let's do calculus. Here we go. Calculus. This is where you must pick up marks. This is the easiest topic. We're just gonna do question 8 due to time. Gonna do question 8 due to time and finish question 8. Next time we'll do question 9 and question 10. So if f of x is equal to 4 over x, from the first principles, which means we must use the first principles then. Let's solve calculus, question number 8. Let me use a different pen. Great. Question 8, from first principles. How are we going to do that from first principles, guys? How are we going to do that from first principles? We know the equation from first principles, so we must apply that equation. So now let's use our first principles equation. We know that, f of x initially is equal to 4 over x. So from first principles, what do we know? We know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So now we have to determine the value of f of x plus h. So f of x plus h, we know that it will be 4 over x plus h. Now let's go. Limit approaches 0. Then what is our f of x plus h? That will be 4 over x plus h minus 4 over x. Then now in this case, since we are dealing with fraction, let's put our division like this, divided by h. Okay, now let's go limit as h approaches 0. Then now let's look for the common factor between the two. Then it will be x plus h. You multiply the denominators. Then now we have 4x minus 4x minus plus 4h. Okay, then we are still dividing by h. So to prevent wasting time, okay, let me just show that part as well. So now the limit of h as it approaches to 0, then now it will be 4x minus 4h all over x plus h and x. Then we are dividing by h. Okay, so that you don't say I'm confused. Okay, good. 4x minus 4x, 0. Then now we have the limit as h approaches 0 of negative 4h all divided by x plus h and x. Right, then now the reciprocal multiplied by 1 over h. Right, Then this h and this h, they will cancel each other. Then after that you move. Then now we have the limit as h approach 0 of negative 4 over x plus h times x. Then now we substitute h into the function. Then now we have negative 4 over x plus 0 times of x. Then now our f prime of x, according to the first principles, it will be negative 4 over x squared. All right. That's our answer. So we use the first principles equation. So bear in mind that on your question paper, there is a formula sheet. So at the back, check your formula sheet so that you can have everything aligned on the straight in a format that you can be able to understand. Okay. So that will be our answer according to the first principles. 5 marks is ours. 5 marks is ours. Okay. What is the next question? What does it want? Okay. Determine dy over dx if y is equal to, wow. So do you see that paper 1 is where you must pick up marks? Pick up those marks, because basically paper 1, it revolves around algebra. So we are given y is equal to 5x squared plus 5x plus 2. So now we want to differentiate. Now we can now say dy over dx. Dy over dx is equal to 2 times 5 is 10. Then x, 2 minus 1 is 1. Then 1 times 5 is positive 5. 1 minus 1 is 0. And anything to the power of 0 is equal to 0. Then the derivative of a constant is equal to 0. Then after that, this is your answer. Just like that. 8.2.2. Now we are given dx of 3x squared minus 1 over 2x. Now they give us fractions, they give us sets, they want to scare us. Don't be scared, because how do you solve sets? You already know that when you're given square root of a n to the power of m, this is the same as a to the power of n divided by m. So now let's use that information which we know. So it's going to be dx of x2 over 3 minus 1 over 2x. Now let's remove the dx so that we can actually differentiate. So when you're given your notation in dx, when you're differentiating, now you remove the dx. When you're given your function in the form of y, when you're differentiating, now it's going to be dy over dx. When you're given a function in the form of f of x, when you're differentiating, it will be f prime of x. So now let's go. So now what do we have here? It's going to be 2 over 3x. Then 2 over 3 minus 1 over minus 1. That must give us 1 over 3. What do I edge? Use your calculator. Use your calculator. It's always there to save your day. Don't worry about anything. Just use your calculator. Okay. So it's going to be 2 over 3 minus 1. Because 2 over 3 is 0.667. So minus 1 is going to be a negative 1 over 3. Okay. Then 1 times negative 1 over 2 is negative 1 over 2. Then 1 minus 1 is equal to 0. So this will be our answer. Just like that, you have your 5 marks in the bag. Okay. 8.3. Given p of x is equal to x cubed plus 2x. All right. Show using relevant calculations why it is not possible for a tangent drawn to the graph of f to have a negative gradient. Show. How can you show that? What do we know about the gradient of a function? Yes. So you're given a statement that show using relevant calculations why it is not possible for a tangent drawn to the graph of p to have a negative gradient. So what are the keywords which we have here? We are given the keyword gradient. Oh, okay. Also, we are given also a tangent. What do we know about these two? They have something which is in common, because when we're starting and we're having dealing with our calculus, we say that initially on the polynomials, we say that the tangent of a graph is equivalent to the gradient of a graph is equivalent to f prime of that specific x coordinate. So what is important is to be able to determine the first derivative of the function. So the first derivative is f prime of x is equal to 3 times x, that will be 3x, then 3 minus 1 to be 3x squared plus 2. So this is our function now. Okay, so this is our first derivative. So after that, what do we know? We must all understand that it is possible for you to determine all this by having the mindset that p prime of x must be greater or equal to 2 because of the y value which we are having here. So what is pre prime of x? It will be 3x squared plus 2 is greater or equal to 2. Then that will be 3x squared is greater or equal to 0. Then our x squared will be greater or equal to 0. Then we know that, i.e., p prime of x now will be greater than 0 because square root of 0 is it's 0. Okay, so that will be our answer. So you can actually say that now by saying like nice English to explain to them after you've done everything. You can actually say that all tangents to p have a gradient that is greater or equal to 2. Okay, so now you can actually write it in nice English so that they can actually understand that you understand what you're saying and you are linking the tangent and the gradient. So that you say that all tangents of the function to p have gradient greater or equal to 2. What does that mean? Thus, the gradient of the function won't be negative. Okay, so after that, so what is important is to be able to link the two. So we are done linking the two, then after that we can see ourselves enjoying our lives at the same time. Then now, how many marks do we have in the bag? All those marks are in our side. We took marks in solving for x. Now we're already above 50%. We are taking marks, going to a distinction. Don't worry about anything. Make sure that you understand the concept and understand the question. What does it want? So this is 13 marks. 13 marks is in the bag. Now we are given this function. Oh my word. This function in question 9. We are dealing with calculus, but we are given a parabola. So what is important is to understand that the derivative of a cubic function, which we are dealing with here, is a parabola. So that's the derivative. So in this instance here, we are given that the graph of y equal to ax squared plus bx plus c below represents the derivative of f. So that means that the derivative, or when we differentiate the cubic function, the original function of a cubic polynomial, we must be able to get a parabola. So in this instance, they plotted a parabola for us, and also we are given that f prime of 1 is equal to 0. What do we know about f prime? We know that f prime at maximum or at turning point, it is equal to 0. So if f prime of 1 is equal to 0 and f prime of 3 is equal to 0, which means those coordinates, they are our x, or the values of the turning point. So we can actually plot the original function using what we already given here. Great. Write down the x coordinate of the stationary point of f. Stationary points, we say that we know that when we are determining the stationary point of a cubic function, we must let f prime of x to be equal to 0. So when we are letting f prime of x to be equal to 0, what does that mean? Which means you must be able to have that clear mind now. So we read the question, we analyze the question. Right. Let's solve the question. Solve the question which we have. Question 9. Question 9, the last question of the day. Solve it. Great. Now, the question says, write down the x coordinates of the stationary points. So what do we know? We know that at stationary point, f prime of x is equal to 0. That's what we know. And when we are calculating the stationary point, we say that after we derive the cubic function, we always say that at stationary point, f prime of x is equal to 0. Then after that, so that's the same instance which we are using. So initially, since they gave us that f prime of 1 is equal to 0 and f prime of 3 is equal to 0, so we can actually use the knowledge that those two, they are our stationary points. So we can just say 9.1, x must be equal to 1 because we are given f prime of 1 is equal to 0, and we are also given f prime of 3 is equal to 0. and f prime of 0 is equal to 6. Okay, cool. So we are already seeing that this is our stationary point because we say that f prime of x is equal to 0 at stationary point. Okay, so now x is equal to 1 and x is equal to 3. Then now we have our stationary coordinates. 9.2. For which values of x is f strictly decreasing? When they say strictly decreasing now, where is this function strictly decreasing? We know that the function of f strictly decrease when f prime of x is less than 0. So since now we have the two coordinates, which means this function will be strictly decreasing between 1 and 3, because now we already determined the x values of the stationary point. So now we know that the function strictly decrease when f prime, or the first derivative of the function, is less than 0. In other words, the gradient is negative, because f prime, we say that f prime of x is the same as the gradient of the function. When we are saying that when the gradient of the function is less than 0, or when the gradient is negative. So now we can actually say that from the stationary points which we have, the function will be strictly decreasing from 1 to 3, which means x must be less than 1, but x must be greater than 1 but less than 3. Sorry for that. Now let's do 9.3. Almost done. Explain at which value of x is the stationary point of f we will have the local minimum. Local minimum. So in other words, we know that our function, or our cubic function, is in this form. So what is the local minimum? This will be the local minimum. So in order for us to determine, we can actually see that it is somewhere here. So what can we say about this? Or which value has a lower minimum? So we can actually see that for a point, you can write this small English for a point, because it cannot be here. Here is 1, here is 3. So this is the local minimum. But now let's deduce, or let's look from all sides, negative side and negative side. So now we write that for a point close to 3, because this is the local. So we know that when we are calculating, we never say 0, 3, 1, 2. No, we say 0, 1, 2, 3. So we can actually see that 1 will be this maximum point, and the local minimum point will be 3. But now let's now look at our sides now. So that's, we're saying that for a point close to 3. So when I may be like 2.8, 2.9, 3.1, 3.2. So we're gonna look if x is less than 3, then f prime of x, we know that it will be less than 0. Then f is decreasing. Then if now x is greater than 3, so it's like a number line. This is our 3. We look at when the values of x are greater than 3 and when they are less than 3. Then after that, we use that. So if x is greater than 3, then our f prime of x now will also be greater than 0. Then f will be increasing. So this part is when f is less than 3, and we can see that the gradient is negative. We can see that f prime is less than 0. Then this part is now 3.1, 3.2. So that's where the graph is actually increasing, which is greater than 0. So now we can actually say that therefore f has a local minimum at x is equal to 3. It has a minimum at x is equal to 3. It has an minimum at x is equal to 3. The next question says 9.4. Determine the x coordinate of the point of inflection. It's 1 mark. It's 1 mark. So in order for us to determine the point of inflection, we know that we look at the 2 points of the function. So this and this divided by 2 will give us the point of inflection. Okay, so that's easy. What do? We know that f prime of x must be equal to 0. So what do? We just say, let's just say x2 plus x1 is equal to 2. That's the point of inflection. Point of inflection will be x2 plus x1. What is x2? x2 is the maximum, local maximum. f1 is x1 is local minimum. So what is our local maximum? 1 plus 3 divided by 2. That's 4. 4 divided by 2 is equal to 2. So that will be our point of inflection. Then after that, the last question of the day. For which values of x is f concave up? We know that f concave up when we look at our f prime prime of x. So it concaves up if the point of inflection is greater than 0. So what was our point of inflection? Our point of inflection was 2. So f prime prime of x will be greater than 2. So now you can just say the x value must be greater than 2. Then after that, you are done. Then you get your 9 marks. So 13 plus 9, every mark count. Okay, so that was it. That was our calculus, which I had for you guys today. I hope you enjoyed. I really enjoyed so much. Really enjoyed. So please do ask questions if you have any questions. It was a nice session. If you have more questions, please do ask on the WhatsApp group. And also, if you are first time watching us, please do subscribe, please comment, and also share with friends, and join the WhatsApp group so that we can assist each other and help each other through with the content. Let's prepare for our June exams. Wish you all the best. Have a good evening.